Hi guys, so we are live after, and we'll see what we are going to talk about today. We actually don't have a script or anything. Dinul, what's up with your work?
Nothing much. I believe you were asking some questions.
Yeah, now you're working in terms of related to things like REST calls, right?
Yeah.
So now let's say, could you please give us a brief introduction on what you are actually doing and the things that you have learned with the past few months and all?
Um, you could make it something specific. Like for
No, no,
example,
I mean, like from your point of view, what should be elaborated to another person? Whatever you think, feel free to talk.
um, well, I don't have anything specific like that. If you want to start with your JavaScript exploits, that's fine.
Uh, okay, then Rismi.
Yeah.
Now, we actually had a small conversation a few minutes ago, and Rismi is currently now working with React, and he's loving JavaScript, right?
Yeah.
Okay, so I am also actually working with JavaScript, and uh, I would like to know what the point of, I mean, the reason for you to fell in love with JavaScript.
I mean, it's all about personal opinion, but in my, it's just it's it's just so easy to just go through the coding. Just
Why do you say that? I mean, now we have done things with Java. We have done things with Python.
mm,
Python is also a modern language.
yeah.
But what makes you really fell in love? Because now we did application together with Java, right? That's also mobile application. And what's the
Yeah.
difference that you see with this and the mobile applications that you are working right now? And what is the reason for you to say
Yeah.
React is easier for you to code than using native Java? That's the question that I'm seeking.
All right. So first now, okay, we'll just take a native Android app for example.
Okay.
So the way you go, you just use Android Studio for that.
Yeah.
And then you create a new project, then you give some template or something, then you give the package name,
Hmm.
and then you select whether what language you want, whether it's Java or Kotlin.
Okay.
And then you have to and then it'll come, I think you'll have to start on your main activity.
Yeah.
So that's where your main code is there, no, that will run first as a start.
Yeah.
And for each activity you have a layout.
Yeah.
So that layout is the UI. So you have to design your UI in XML format, and then use them in the main activity class, and do all the logic and stuff.
Not in the main activity, but the responsible view, you mean, right?
Yeah, but the main activity itself has a layout, right? That's
Yeah,
where it
yeah,
start now.
yeah, yeah,
So after that, yeah, you can go to other layouts and stuff.
yeah.
So then you have the manifest file which have to define all the characteristics and stuff.
Hmm.
Then you have the gradles which have to, there's the module level gradle and the app level gradle is there.
Yeah,
So you have to give all the dependencies, then I think the minimum SDKs and stuff.
yeah,
So that's how it is for just for native Android, right?
yeah,
And then then you have to learn everything about the views and stuff in Android, how it is, all the
yeah.
layouts and stuff, the boxes, the buttons, and all those other stuff,
Okay.
the widgets and stuff was there, no? Then that's the layout, what you call the,
Activity layout and stuff.
yeah, then there's this yeah,
Sorry, relative layout and stuff, right?
relative layout, yeah.
Yeah, which basically puts the buttons and stuff relative to the other items that you have on the display, right?
Yeah, yeah,
Yeah.
yeah, yeah, yeah. And then you have the all right. So that's how you basically just the basic app you start, right?
Yeah.
So in what's difference in React Native is now it depends whether you're using Expo or CLI.
Uh-huh.
Okay, then you just using terminal, you just create a new React Native app. Then you go to your app .js, and then you can just start on. It's just the main file that will run first, depending on the index.js which you are given.
Okay.
Yes. Then after that, you can design and do the layout and logic all in that main app.js.
Okay.
And it's just you just have to know about the JavaScript and the React Native components.
Okay.
So you have to use each React Native components for the UI part, or you can use some external libraries and stuff.
Okay.
uh, and you can just design it
Uh-huh.
and just run it on Android.
Okay.
And what's difference is that even it's cross-platform, right?
Yeah.
So you can run it on iOS and stuff, but you don't have to do any changes at all to your code.
Okay.
That's what the main that's what they say the React Native, right? Learn once, write anywhere.
That's what they say, because that's is that what they say about React.
Yeah, that's what they say. No, you can learn once and write anywhere.
Uh-huh.
So
So, just want to point out few things.
yeah,
Now you were talking about React components, right?
yeah,
So I'm just curious, right? I'm just asking. Now let's say you have a button
yeah,
in as a React component,
yeah,
and now when you want to place it on the screen,
yeah.
what are the options that you have, and how do you actually place it?
I mean, can you like,
Now let's say we have a login screen.
yeah,
So basically, we'll be having two text boxes for the username password
yeah,
and but let's say one button for login, right?
yeah,
And now in Android, we can have the relative layout. So with the different screen sizes coming into the picture,
yeah,
it will automatically adjust according to those scales that we have given. I mean, in considering relative layout, right?
yeah, yeah.
Uh, uh, but how would such a scenario will happen in terms of React?
So in terms of React, they use the Flexbox.
I'm not aware of that. Could you please?
So Flexbox is used in CSS,
Uh,
where the is basically the layout. You say now in React Native you call it Flex, so it will define how you are going to how you fill the space in your app, in the main screen. How you're going to fill the space. That's what Flex is there for.
uh-huh.
So now if you have say you have two views,
Okay.
so now everything comes under view in React Native.
Okay.
So in the view you can give a style of Flex. Okay.
So, but now let's say, Machan, that now let's say that. Sorry for
Yeah,
interrupting,
yeah,
but
go ahead.
just to get the idea.
Mm-hmm.
Now let's say we have two phones. Okay,
Yeah,
one is 4-inch screen,
yeah,
the other one is 6.5 inch.
yeah,
Now, now, how do we like now if we use this flex box,
yeah,
will it automatically adjust according to the screen size?
yeah. Because it's just now when it takes a value, no Flex takes a value. It's either one, two, three, or whatever.
Okay.
So when there are two views, you can give Flex one for one view, and you can give Flex two for another view.
Uh-huh.
So what it means is that it will take like one part two. Okay, so out of three, no, so one third of the screen will take by the first view, and two thirds of the screen will taken by the second view.
Uh-huh.
It's until and only that's how Flex works.
Okay.
Don't they know
So
Flext is a registered trademark?
It's without the T.
I'm gonna go to coach tomorrow. Dinner, you want to join?
Yeah, yeah.
Yeah.
Tomorrow
uh,
courts are closed.
Yeah.
Just
Native is gonna get. They gotta bag some cash for us.
so the but just saying my
Yeah,
view right now, Machang, you were saying that you can code everything under one page, right? And I mean under one
I mean you can, but you don't generally do it though. But
and
yeah,
yeah, that's what I
I mean
just
it's
want.
better to keep the layout part different and the logic part completely different.
Yeah, that's what. Otherwise, scaling will
Yeah,
be a
yeah.
problem. Right?
It's just going to be chaotic.
Yes. So in that terms, Machang, it's I mean the only advantage. So I mean, of course, you have the advantage of cross-platform. That's a huge advantage.
Yeah.
But I'm just curious to know why it's easy to learn than Java. Java. I mean,
I mean it's basically the JavaScript, right? It's built on JavaScript, no?
yeah.
I mean it's just in my experience, it's easy than the Java.
Mm-hmm.
All right,
Okay.
that's what I feel like.
So you're using TypeScript or JavaScript for this?
Right now I'm using JavaScript.
JavaScript. So in the future you're moving into TypeScript or
Yeah, yeah, definitely I do because it gives more what you call type errors and stuff. This there you can have more control over that.
yeah. In that case, you will kind of run the TypeScript first, and it will create a lib inside your directory, right? Is it?
The creator,
It will create another like a subdirectory called lib, and it will have all whatever you have on the TypeScript will be also there in the JavaScript side. Is it?
I don't think so. It's just TypeScript. I don't think there's JavaScript involved.
It is Masha, because as as far as I know,
Yeah,
TypeScript what we'll do is JavaScript is dynamic, no?
yeah.
So like you said, Majang, because
I
of
mean,
that,
I mean
yeah,
TypeScript is just an extension of JavaScript, no?
yeah. No, actually, TypeScript converts your code to JavaScript, Majang, pure JavaScript, and then runs it.
Is it?
Yeah, yeah.
Okay, okay.
But the problem is this, Majang.
Yeah,
Now, in anything we have advantages and disadvantages too.
yeah,
uh, of course, like you said, the type errors and stuff will be easy to handle and all that,
yeah,
and maintainability, readability, all this will be improved.
yeah,
uh, but then again, the problem is, if you look at the, it's not a problem, but just saying, if you look at the JavaScript, which is because you run the TypeScript and TypeScript will convert everything into JavaScript. No, so if you
yeah,
look at that JavaScript, Machan, because it's machine generated,
yeah.
it looks very ugly because the namings and all that are not like how you have,
Yes,
instead
but
of,
but ultimately it doesn't matter, right?
yeah, yeah, yeah,
Because that part is just for the machine. It's not for you. What you do is what readability is important for what you work on. No?
yeah. I am not 100% comfortable. I agree with you,
Yeah,
but sometimes I think they like, let's say, when we use certain libraries,
yeah,
they ask us to change the JavaScript, like, let's say, they will ask us to make a variable true of also something very small minor things. And if you, anyway, but anyway, just saying, if you look
yeah,
at that, it will be not nice as that. But I totally agree with you. The point is that you have the TypeScript to look at. Why should
yeah.
you look at the JavaScript? Yeah. Dinura,
yeah.
Machang, now let's say you're working, what framework are you particular
So,
working?
what we have trained with is Spring. So this is microservices. That's the area that we're kind of in.
Okay.
Um, but yeah, Spring is also kind of it adds a lot to Java, etc. And not just Spring, but using Maven and dependencies. All those things are quite new.
Okay. So
New to
earlier
me, that
you,
is.
huh?
New to me, that is.
I mean, of course, I mean, we all are learning new things, new stuff. And as a software engineer, that's one of the key things that we should tell everyone. That's uh, as developers, it's not like being, uh, I mean, it's not like other occupations where you learn something and you practice that for your entire lifetime.
Hmm.
With being developers, you need to learn new things in a regular basis, and you need to apply that. Basically, it's problem solving, but there'll be a hell of a lot of time spending into R&D, research and development. Research part will be there if you're a developer, right?
Yeah, and it's
So
self-training. It's mostly self-training.
yes. Dinur, could you elaborate on the stuff like you were earlier? We had a discussion and you were saying
Yeah,
that.
you were
Uh,
asking me a question. I don't remember it.
yeah, no, we'll just have a brief intro into that. Uh, so you were saying that what we have learned as Java, and I mean in terms of what we have learned in Java is not what you are actually applying to, as in like you
Well,
apply the concepts,
I
but
mean, the syntax is the same,
yeah,
but yeah, I mean, when you work with a framework, a new framework, it's different. So while using these dependencies such as Spring, you use all these annotations to specify things like data entities, and the way that you connect to databases and all that is different. So if you haven't used things like maybe .NET in your university, this might be new to you, but um, it's like a different system. So yeah.
I mean, but now you were saying this. Now you were saying about these annotations and stuff, Nemada.
Yeah,
Now let's assume you are using. I'm sorry, I forgot the framework. What was it?
Spring.
The Spring, which is a very widely used, very industry approved framework, right?
Yeah,
Which they used for enterprise applications. So coming back to this Spring Masa, now let's say that you want to do a microservice architectural application, right?
yeah,
And you are using the Spring framework, right? And let's say you are doing a REST API, okay?
yeah.
And
Microservices usually the concept we use is REST. So yeah,
yeah,
I mean microservices basically what you have is a bunch of services. So each service is isolated. So the two conditions for microservices, it should be able to run independently and it should be able to start independently. I think that's sort of wrong, not the exact phrases, but basically these isolated services are running, and between them there need to be calls. So usually we use REST and HTTPS to do that. Yeah, go ahead.
yeah, and so since we talked about that, could you elaborate in terms of now with microservices? Because I have seen people getting confusing with microservices and the NT architecture, right? I mean, in terms of microservices, can you have two instances running in the same machine? You can, right?
It's not about machines, it's
So
about services.
yeah,
And running two microservices on a same machine is possible, and it is done.
yeah,
But I mean, if you have a single, so it's like this. It's not one machine. It's if what you call a machine is in a production environment. So
Yeah.
you will have rooms and rooms full of servers, right? So if
Yeah.
you want to deploy microservices, it's not possible to just have a single computer per service, right?
Yeah.
So what what happens with microservices is it runs on top of a virtual machine, usually something like Docker or Kubernetes,
Mm.
right?
It's not required, but you can do that. Yes.
Not required meaning, I mean, you like that is one way of achieving it. I mean, the only other way I can think of is having an individual machine for every service, and that is not feasible at all.
Uh, no, no, now, now, uh, why would you say that, Maja?
Why would I say so? In a production environment, you will be running thousands of services.
Okay,
A single machine for one service makes no sense.
makes no sense. Yes,
A
totally
single
agree.
virtual machine for one service makes sense.
Yeah, but here's the thing. Now, just coming back to the in tier and this because people get confused, right?
Uh-huh.
Just want to point it out, and we'll come back to this. So, in the terms of n tier, there'll be different machines, right? So,
Yeah, by NTA you mean the basic monolith, right?
yeah, and right now, so we have to tell them about this monolithic architecture and why we are moving to. We have already done it. We have why we have moved to microservices. So, could you please elaborate on that, Masa?
So a monolith is like it's just like the name. Imagine it's like a huge building or structure, and if you want to, let's say it's so Netflix, right? Let's say
Yeah.
Netflix was built on a monolith system. So Netflix, if you don't know, they pioneered the microservices concept.
Oh, I see.
So yeah,
Okay.
so if Netflix was built on a monolith, right?
Yeah.
Netflix would be just the Netflix service would be just this one giant structure, right? And
Yeah.
this structure could collapse internally.
Yeah.
Whereas microservices is where each functionality is separate. So login is separate, and um, the video streaming service, if you were Netflix, it would be separate. Netflix doesn't have a comment system, right? So um, the recommendations and all those algorithms are separately stored in microservices. So I mean, so where you could get confused, for example, is even in a monolithic system, we separate the services, right? We don't program everything in one class or anything, or we split it into packages and all those things. But this is not, this is different. So it's like every service is a different program running on a different machine.
Exactly. Yeah. So the idea is that in a monolithic application,
Yeah.
basically you design, develop as one single piece, and you whenever you want to make a change, you have to take that entire application, that big application, and make the change, right? And
Yes, that is
in
a monolithic architecture is like one super brain, right? A single massive brain, and the microservices is like a hive mind. So multiple smaller brains linked together. So
exactly.
one of those can fail, and they can be replaced. That happens regularly.
Yes,
So
and
these
for
services they drop off, and yeah.
yeah, so
So and the concept is you can have supply and demand. So if lots of people are logging in, so let's say Netflix runs an offer or something,
yeah,
and so there'll be suddenly an increase in the number of people logging in and
yeah,
subscribing, right?
yeah,
So you can generate more of the subscription service. Just the subscription service, you can have 1,000 or so, and you can
yeah,
increase it to maybe 2,000 to
yeah.
meet the service demands without expanding the entire system. So yeah.
Yeah, and the maybe the you don't need to stop the existing systems in order for you to expand, right? And
No,
that's
no.
Yeah. So there are a lot of benefits.
Yes, there
Uh,
are a lot of benefits, but
in
it would take more processing power, and um, I wouldn't say it's more difficult to program. Maybe it's easier to upkeep though, because you have all these separation levels.
Yeah. So we can say it's loosely coupled, right? In terms
It
of
is it is loosely
using.
coupled. Loose coupling is the concept itself. Basically, if you want to go to basics, uh,
Yeah. Yeah. So
yeah,
we are just basically having that what do you call? We have a huge application. Uh, we don't go and build the entire application as a one brick, but what we do is we create smaller parts of the services, which uh, services are things that which needs your application to run, right?
yeah.
And then we using those services, we can run a single application. I mean, there'll be multiple services in terms of in a microservice architecture, but it may be all of those services may be there for just one application, right?
Yes, yes, it can be just for one application, but usually, I mean, in any system there will be at least five services, I would say, or four.
No, I'm saying application in terms of the end user. I mean,
Uh,
there may be multiple services, but all these services are there for maybe now if you take Netflix,
yeah,
instead of uh, using monolithic architecture, now you have microservices, so that all these smaller services are catering for that end user Netflix application, right?
yes.
So the benefit is it's easy to maintain, I would say.
No,
I have
no,
a
that,
small
yeah, go ahead. Can
Yes,
I,
Didn't,
not,
didn't I recall you saying that microservices is like different code in different machines used to uh, like cater for one application, is it?
it doesn't have to be one application. I mean, so, so it's like this. What we usually do is, these services, they run on a network, right? So
yeah,
there's a huge networking side to this. So what we usually do is, we divide the network into two parts. We have a private subnet and a public subnet, right? Okay.
Yeah.
So the private subnet, no one can access from outside the network, right? But the public sub, sorry, I said the private subnet, right? The private subnet cannot be accessed from anywhere outside the network. So
Yeah.
what the end user will be talking to is a service on the public subnet, right? So the once the request goes into the public subnet, it really doesn't matter what happens inside the things, because it's all rest calls. There's no, this is stateless. It doesn't matter what requests are going in out throughout this network. The reply is going to come in, right?
yeah, yeah.
Does that answer your question? I don't understand it.
No,
I
no,
don't
no.
need it.
I think we are doing a general okay. It's not just okay. It's generally super explanation for our these people. I mean, if you are hearing this for the first time, don't get disattached or anything. You just go and search through. I mean, with time only you will get the actual idea, right, Denver?
Yeah. And
Uh,
before you said, what did you say? The main advantage of microservices. I can tell you why Netflix uses microservices. It's
okay.
because of their huge. It's because of their huge supply and demand chain. I mean, Netflix transfers and it's an unimaginable amount of data, right?
Yeah,
So all of this data coming in has to be processed, right?
yeah,
So that's why they have this system where this data can come in on separate streams, and it's like yeah, it's bouncing here, and all these requests are bouncing here and there, instead of having this set algorithm for dealing with things.
Okay.
So yeah, some interesting stuffs that I learned.
Yeah, yeah.
We all are learning.
We all learned some interesting stuff, and
Definitely.
I
That's
think
that's
this
the
whole 30 minutes was, I mean, 35 minutes almost. It is really, really things that I learned, new things
Yeah.
we'll
from
yeah, go ahead.
TypeScript to JavaScript to all these microservices to all these stuff that you guys are talking about is like something really new to me also, and maybe new to other people also.
Yeah, so we hope you picked up something, and we might have made some mistakes there. If you want to correct us, please do.
Yeah, there's a comment section
Yeah, and there's an official
open for
email.
discussion.
There's an official email you can visit.
Yes.
So yeah, I think that's the end of this episode, is it?
Yes.
Yeah.
Does anyone have anything to add?
I think that's a no.
Yeah, that's a no. Um,
Thank
all right
you.
then. Thank
Thank
you
you
for
for
listening.
listening to us.
Yeah.
Do all the good stuff.
Yeah.
Comment, subscribe, and
Comment.
share. And
You know
all
the
that.
drill.
All right.
Click the bell.